So an instructor I worked with one time, I got angry because we were working with aspirin tablets, and the thing with aspirin tablets is that they're not very pure because most prescription drugs you take typically don't have that much material in them. And it was like, well, yeah, I mean, the real world isn't composed of all these perfect mixtures that are like exactly what you want it to be. They're not like 1/3, 1/3, 1/3, whatever you're looking for. So here's an example where we have our filtered material and like there's just a lot of junk on this. So I took my filtrate from earlier, poured it into a flask, and I'm already starting to get a little bit of precipitation here. This might have been some of the liquefied or inorganic that made its way through, or liquefied material that made its way through. But the next step here is we're going to acidify. And this is going to be pretty difficult to work with, but we're going to make it work. What we're doing by acidifying is we're taking the fatty acids and we're converting them from carboxylate ion form back to the their organic form, so the actual carboxylic acid. So what's going to happen as I start doing this is it's going to start getting more and more chunky in there. It's going to start seeing the organic start crashing out. Now what we're also going to have to do when we're doing this is neutralize out all the unreacted sodium hydroxide from earlier. So it's not like this immediately occurs. We have to give it a little good swirl in order to make sure we've got like everything reacted away. But now I'm kind of getting like the snow globe effect, and these flakes that are forming here are actually the palmitic acid that we're trying to isolate. So let me get a little bit more acid. Now the other complication here is we are forming soap, and because we are forming soap, there's going to be a lot of junk that carries over with it. But we're going to do our best, and so now we've got our nice snow globe effect going, and we're going to drop this into the ice water for about 10 minutes. And once everything gets done crashing out, we'll be ready to do the final vacuum filtration. All right, my material has pretty much precipitated out at this point. I've got a nice layer of what should be the palmitic acid on top. So I'm going to turn the vacuum filtration back on. This will be the last one we do. Once we get this filtered out, we're going to add another 20 ml to kind of rinse out the flask. Now, the challenge with this one is going to be the fact that it is kind of a waxy material, so it's going to want to gum up the filter paper pretty hard. So we just got to be patient here. So what I'm going to do is I'm going to let this run for about 5 minutes. We can't dry this in the drying oven because the palmitic acid actually melts the temperature, melting point beneath water. So we're just going to have to crudely scrape this onto a watch glass and weigh it that way. Unfortunately, this is going to have impacts on our yield, but it's the best we can do in terms of what we're working with. All right, so there's my isolated product there. I got 1.58 grams of material. Now, we're not going to really worry about yield here because palm oil is a raw material, and so we'd actually have to do an assay or an analysis of it to figure out what composition we'd expect. There are a lot of materials that we expect just to kind of come off this material. We also expect to have various losses, but this is kind of what we'd expect for palmitic acid. It's actually kind of a white, waxy solid. No strong odors. Again, our starting palm oil was actually a yellow color when we began with. These white crystals here are a lot more consistent with what we expect to see. So next thing we're going to do is we're going to try a melting point, and we'll talk about that in a minute. This is actually kind of a difficult thing to take a melting point of, but we're going to try to approximate it using a hot water bath.